as the studies goes on, the influence line diagram we have been discussing in the previous class. I repeat the same that question, the problem statement once again, because why I am concentrating on these questions is uh, the question is raised in the final year examinations, and that is the only one question in the section that is carrying all full marks for the section. And these questions will be compulsorily asked in every semester end exams. So that is the case I am concentrating on this, and adding to that, these problems are very much easier just to get complete marks, because uh, nothing problem we are doing here, just we are taking the similar triangles and coefficient values multiplying with the intensity of loads. So that is the case. In this problem statement, if you read this, it is clearly shows that what data is given, what they have asked. So the draw influence line diagram for a bending moment at a point 10-meter distance from left hand abutment. So abutment in the sense when it is considered the bridge, that is a part of the bridge abutment. Say it is a bridge, at the end supports are considered to be an abutment, and supports which is in between the end supports are considered to be an piers. So the abutment they said, that means this is abutment, and that part of the bridge need to be considered in the question. Bending diagram for bending moment at a point 10-meter distance from the left hand abutment on bridge girder of span 25 meters. So total span of the bridge girder is 25 meter, and for the 10 meter from the left hand support, that need to be calculated with the maximum bending moment, and find the maximum bending moment at the point due to a series of wheel loads, 100 to 100 200. There are five numbers of series of loads at a center to center distance of 2.5 and 4 respectively, and the loads can cross in either direction with 100 kilonewton load leading in each case. So in the case if the bridge is moving with a series of loads, when the series of load is moving, the 100 kilonewton load will be the leading one. That means that will be at the front, and again at the same time, if the same load is moving from right to left, again the 100 kilonewton load will be the leading, just like it is a train of loads. So that is the question they have asked. So in this question, we need to calculate the bending moment at the point C, which is 10 meter away from the left hand side, left support or the abutment. So if you if you draw the influence line diagram for the bending moment, it will look like this. And that means at the point where you are calculating, will be having the apex point, and the distance on either side will be noted down with respect to the point we need to measure. So here in the total 25 meter, 10 meter distance they have asked, the 10 meter is written over here, and remaining 15 meter is on right side. That is the span of BC, we can say. It is the span of, here it is support A. I hope you are observing the cursor. Please concentrate on the point of cursor, because the explanation I could do only with this, with the help of this one. So this is the point A at the support, and at the section C it is asked for 10 meter distance, and then it will be the span of AC, and the remaining span will be BC having 15 meter distance. So here we need to find the maximum bending moment, but here what we uh, need to do is, the series of loads are given here. In the question, the series of loads are given 100, 200, 200, 200 and 200 kilonewtons. So which load need to be on the point C to get the maximum moment? And that is the case we need to solve over here before calculating to the bending moment. Which load or which load that need to be there on the section of C to get maximum bending moment. I hope it is clear what I am trying to explain for you. If the case having the load intensities of different 100 to 100 different types, but which load need to be at the section to get the maximum bending moment, that is the case we need to have a discussion for this. So with this regard, I just take a use of the pen here. Here and the span of AC and span of BC will be considered for the average load. Uh, that means the average load on in that AC should be lesser than the average load on BC, because average load on BC, if it is maximum, then the span of the BC is greater than the span of AC over here. If you observe the question, okay. So I would like to just consider over here. I hope the diagram is clearly visible now. So this is the support A, and this is the support B, and this is the support C, right? So the span of AC and the span of BC we can say. So uh, for this we have a series of loads. Before that, I would like to explain with this. For this we have series of loads. Am I audible clearly now? Else anyone let me know if it is clearly audible.
Yes, sir. Yes, sir.
Okay, fine. And these are the series of loads which are considered on the spanner, that is with a distance of 4 meter for first one, and the remaining are 2.5 meter. This is 4 meter distance and remaining are 2.5. This is 2.5 and remaining all distances are 2.5, here this one and this one. So now it is 100 kilonewton load, and all these are 200 kilonewton loads, and this is also 200 kilonewton load, and this is also 200 kilonewton load. I hope the question is clear for you people, what exactly the series of loads are given. So when you consider these series of loads, the particular load need to be on the section YC, what I am drawing over here. Which load is, if you place the load of 100 kilonewton, how much would be the maximum bending moment? If you place a second, that is first 200 kilonewton on the section C, what would be the bending moment? That is the case. But if you do that case, and then we cannot do for all loads, because it will be time consuming, and it is not good practice to calculate that. So based on this concept, what we can do is the average load that need to be considered on the section. So for example, if the distance of the load from the load to the hinge point is greater, then you will be getting the maximum bending moment. That means what I am trying to say is, if there is a span and there is a load, right? Say it is an 1 kilometer load, you can say. Say there is a span of a 10-meter distance. So the distance is greater, then you'll be getting the maximum bending moment. If the distance is at this point, if you having a 5-meter distance, the bending moment will be 5 meter, 5 kilonewton meters. That is the case of what we are trying to consider over here is. So for span of AC and span of BC, if you consider, the span AC should be having a lesser average value than compared to span of BC. So how do you do that? If you consider when a train of load moves from left to right, so that means from here to here it is moving. That means the series of loads will first cross the AC span and then the BC span. Even it is not like that, you can also consider from right to left. It is not like that you have to consider only the left to right at the initial stage. It is depends on you. You can also consider from right to left. So in this question I have considered the left to right. So on this left to right, if you consider a first 100 kilonewton, the 100 kilonewton load is here with the distance of 4 meter to the next 200 kilonewton load. So if you consider 100 kilonewton load is on the section, so how much load is remaining on the back side? So however, the load is crossing the span of AC now. So 100 kilonewton on the section C, then the remaining load will be on the span of AC, right? So how much remaining load is on the span of AC? Total 800 kilonewton, because 200. Yes, who is this? There are 200 kilonewtons loads of 4 numbers. That is, the total will be of 400 kilo. That is, 4 numbers of 200 kilonewtons loads will be there. Please, who is this? Mute your mic. Supriya. Okay, fine. So if on the span of AC we have 800 kilonewton load, and the 100 kilonewton which is on the section C is considered on the span of BC. So that is what the tabulation, in the tabulation it is written, the average load on CB or BC, we can say, that is 100 kilonewton for the span of 15. For the span of 15, that is considered with the division. So that means we are taking to the ratio of load to the span. So how much load it is there for the span of the 15 meter? It is 100 kilonewton load which is acting, which is considered initially. And now if you consider the ratio of these two, the span, the average load on the span AC is greater than the average load on BC or CB span. Because we have the larger span of BC over here, we need to get the larger average load for the BC to get the maximum bending moment. That is the case we need to understand over here. And the second one, and the second case, our second load is 200 kilonewton. If the 200 kilonewton on the section, if this 200 kilonewton on the section, the 100 kilonewton will be passed to the next level, and remaining how many loads will be there? There will be a 600 kilonewtons. And this 200 and 100 is on the section of BC, and the remaining load, of 200, 200, 200, these three loads will be on the span of AC. So these 200, 200, 200 will be altogether 600 for the span of 10 meter, and remaining load which is on the span of BC, that is 300, 200 plus 100, 200 plus 100, which is having for the span of 15 meter. Again, if you consider the average ratio of these, you will be getting the AC span will be having more average than CV. But our intention is to have the more average load on the BC. So again, now the total series of load is moving again. If you move the series of loads to the right, to have 200 second 200 kilonewton on the section of C. So at that time, the total 200 plus 200, 400 plus 100, total 500 kilonewton of load will be on the span of BC, and remaining this 400 kilonewton load will be on the span of AC. That is what it is considered. A second 200 kilonewton load is on the section of C, then we'll be having 400, but 400 kilonewton on the span of AC, and remaining 500 on the span of BC. And now again it is not satisfied with the average load on the BC, and now the again the load is moving with certain distance to get the 200 kilonewton, that is third 200 kilonewton on the section C, on the section C over here. So if the third 200 kilonewton on the section C, then what would be the loads on the spans? So that is 200 kilonewton will be there on the span of AC for the 10 meter, and remaining 700 will be on the span of BC. So that means average load on the CB is greater than the average load on AC. So that means the load combination, what the load pattern or load point, what we have come to know is, on the span it is in 100 kilonewton for the section AC, for the point C, say if you consider here it is a C point, then the load what we are expecting to be on the section is third 200 kilonewton load. This is the third 200 kilonewton which is having here, and the remaining is 200 here. So the 100 kilonewton and the 200 and another 200, these are all passing to the section CB, and the third 200 kilonewton is should be acting on the C, and the remaining 200 kilonewton which is there on the span of AC. If you have this section load acting on the C, then you will be able to calculate the maximum bending moment, right? So this is what the explanation. Now the same thing will be written in the diagram and then calculated with the bending moment. So if you have any doubts regarding this, please let me know.
Sir, remaining CBL 500 kilonewton has to be there, sir. 700 by 1500.
Which one, for second or third one?
Third one, third.
Third one, yes. Here see total how much load is there? 4 numbers of 200, correct? And that will be 800 kilonewton.
Total 900, sir. Total 900, sir.
In that total 900, if the section on that is, if third point load, that is, I hope you are seeing the cursor, this third 200 kilonewton is acting on the C, then the remaining 200 will be on the span of AC, but which is behind the load. Yes, that is 200 is considered, and remaining 700 kilonewton will be on the span of BC. That means the sum of these two loads should be of 900. Are you getting?
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Yes, this 700 plus 200, 900, 5 plus 4, 9, 3 plus 6, 9, and 1 plus 8 should be 9. Like this, the sum of the load should be 900. Yes, you got it?
Yes, sir.
Okay. Then anyone having any doubts? Because why I'm giving time is, if you understood this concept, then you will be able to do it easily. It is not so much difficult to get it or do it. It is so simple concept, I hope. Just we are moving the series of loads on the span on the section C, and we are calculating the average load. Shall I move forward?
Yes.
Okay. Vinay?
Yes, sir. Yes, sir.
Okay, okay, fine. Shweta, are you listening? Chandrika? Because I want to know everyone over here. Okay. Okay, okay, fine. I will just clear these things. Now, if you consider what we have done, and the load combination is, just I will draw that one diagram over here. So this is the span, this is the span, and we on this span we have a section C over here, and this is A, right, and this is B, right. For this, the load combination load pattern is drawn in this manner. This is 100 kilonewton, first 200, second 200, third 200, and fourth 200 is here. So I will just write this is what. So this section is considered over here, and at that point, if you consider, then you need to have the bending moment diagram or influence line diagram will be in this manner. So for this, if you take the section over here, it is like that. So this is what the actual conclusion what we have done with the previous calculation. So about maximum bending moment in the span, if you consider, okay, here I have drawn this.
Sir, change this.
Yes, I think
This is not the problem.
yes, I think here it is. Yes, yes, yes. I think in the scanning it has got confused. So when the third 200 kilonewton is on the section C, and then it is just on the section. If you just you can observe over here in the diagram, it is been shown that is 200 kilonewton is acting on the section C for a total span. So at this point, if you consider the YC value, how do you calculate? That is again the same thing, z minus z into L minus z by L. The z is the shorter distance and L is the total span. So z is the 10 meter over here, and L minus z will be 15. 15 by total span is 25, and the YC is getting as a 6 over here. So YC is getting as 6, and at the same time we need to calculate the coefficient values for Y1, Y2, Y3 and Y4. So how do you do that? Just here, this is enough. So for y1, how much it is the distance? So here it is total 10 meter distance is there. In this 10 meter distance, we are deducting 2.5, right? If you deduct 2.5, then what would be the distance from the end to the section C? That will be 7.5. Am I right? And again,
Yes.
YC, yes, YC is 6 and YC is 6, it is written. And for Y2, when you cross the section, you need to consider the support, this one. When the section is considered, the section should be considered on the right and left. And the right side of the points or coefficient values need to consider the right support, and left side coefficient values need to consider the left supports. Please do keep it in mind. And when you calculating for y2, so how do you calculate y2? So in total span, how much we have, that is 15 meter. In the total 15 meter, we have 2.5 meter at the distance. So remaining will be the 12.5, right? So in the total span of 15 meter, we are deducting 2.5 and remaining will be 12.5, correct? So 12.5 for the distance of 15, that will be the coefficient value for y2. And at the same case and the similar case, if you consider for y3, so how do you consider y3? Y3 will be the distance of from the B. 15 minus 2.5, 2.5 will be 10 by 15. And for y4, how do you consider? So y4 will be considered 15 minus 4 minus 2.5 minus 2.5 will be 6 divided by 15, right? Is that clear? And at the same time, once you know the coefficient values for the sections of the load, we need to just multiply the intensity of load to the coefficient value along with yc. Please keep it in mind, and the yc need to multiply with all the sections because the load is moving. The coefficient of yc that need to be considered along with the all sections. So first we have 200 kilonewton load, 200 kilonewton load having a coefficient value of 7.5 by 10 plus 200. Again the yc will be multiplying all over at the end, and this third, that is second 200 kilonewton load having the coefficient value of y2. Y2 is 12.5 by 15. 12.5 by 15 plus 200 into 10. 10 by 15 and plus 100 into y4. So y4 having 6 by 15. Altogether we need to multiply with the yc coefficient because the moving load. So total load will be total moment will be 4140 kilonewton meters when the load is moving from from left to right. Dear students, is that clear? How we have calculated maximum bending moment? Please talk. Don't mind anything if you talk here. Please uh, clarify your opinion.
Sir, explain once again.
In which part you are having doubts?
YC.
YC. So YC
Yes.
is C. This is the general formula. We know that in a previously we have solved this one. So Z into L minus Z by L. So Z is the distance where on the span the section need to be considered. The span on the which we are going to calculate, that is the span, that will be the Z value. That means the lesser value in the span is considered to be Z and remaining will be the L minus Z. So L is the total span. L is the total span of 25 meter, and in that L if you deduct this value of Z, and we will be remain with this portion. I hope you are observing the screen. This 15 meter will be the L minus Z. Just we are substituting the value of Z as 10 and L as 25. Right, that is the case. Then you will be getting the YC value. Yes. So anyone questions? Anybody having any questions? Okay. So what we have discussed till now is the calculated bending moment when the series of these loads are moving from left to right. Right, from left to right the load is moving, then the total bending moment is 4140 kilonewtons. So if the same case and the total bending load moving from right to left, so when the train of loads moving from right to left, then what would be the bending moment on this case? Are you getting the question? What, how we are solving for this? Here the load is moving right to left over here in this direction. In the previous problem what we have calculated, this bending moment is on right to left. Sorry, this is left to right over here, and here it is right to left. It's moving in this manner. From left it is moving to right. Here from right it is moving to left, and the direction is changed. But the series of load is said that the 100 kilonewton load will be leading in either of the direction. In either of the direction, if the load is having the moment, the 100 kilonewton load will be leading. That is what given in the question. And the same concept, if you consider the section C, and again we need to cross the loads, series of loads one by one. If on the span of AC over here again, on the span of AC like this, and how much load is there on the span of BC and AC, that is what we need to know to get the maximum bending moment over here. So again I would like to take this table over here. Okay, so now I will draw this once again. It is a span of AB. It is a span of AB, and we have a section at C. We have AC span and BC span, and for this we need to cross a load series of loads, having the section at this point. Right, this is 100 kilonewton load first Firstly, we need to consider and this like this, and the other loads are spanning over here. And again, this is 100 kilonewton load, and remaining 200 kilonewton loads are here. Right? These are 200 kilonewton loads. Right. So on this, again, we need to consider a series of loads which are moving, having average on the span of AC and BC. At the first time, if the 100 kilonewton load is on the section C, load crossing 100, at that time, on the span of AC, we will be having 100 kilonewton load, and remaining will be having 800 on the span of BC. On the span of BC over here. So that is what it is written, and taking the value of the average. And again the load is moved to second 200 kilonewton to coincide with the section C over here. At that time, on the span of AC, we will be having first 100 kilonewton, and this second load of 200 kilonewton, and the span of AC is 300. 100 plus this 100 plus this 200 will be 300 on the span of 10 meter, and remaining 600 kilonewton load will be there on the span of BC, right? And this is what how we are getting sum of total loads will be 900 on either side. Again, when the second 200 kilonewton load, this load is on the section C, and on the span of AC you will be having 100 plus 200 plus 200. Total of 500 kilonewton load is on the section AC, and remaining 400 will be on the section CB or BC, you can say. When you consider the average loads, the AC will be having the more average than CB over here. That means the moment that need to be considered over here, when the moment of the load, series of loads are moving in the direction to the front, the section having the front side of the load should be having the maximum average load. That is the case we need to have over here. So for this, what we have done in the previously, the load is moving from left to right, and from on the span of CB we have considered the maximum ratio of load. Again, here in this solution, we are having the load moving from right to left, and the span of AC should be having maximum average load. Right? This is the BC, and here it is AC. When the load is moving from left to right, we have considered the maximum average load on the span of BC or CB. But when the load is moving from right to left, the average load on AC should be maximum. That means whenever the load is moving to the front direction, the span against the load, again the in front of the load, is to be considered with a maximum value, maximum coefficient value. So this is how we have got the second 200 kilonewton on the section C. So if you place the second 200 kilonewton load on the section C, you will be able to calculate the maximum bending moment on the span. So the same diagram that will be considered in the case over here. What we have calculated. See, when the series of loads are moving from right to left over here, first 200 kilonewton is passed, or second 100 kilonewton is passed, but at the third 100 kilonewton is coinciding with the section, we will be getting the maximum value, maximum load average value on the span of AC over here. This is C and this is B. So at this time, again we need to have the coefficient value calculation. So once you calculate the coefficient values, then you will be able to calculate the total bending moment. So that is what the same procedure that is repeated over here. This 200 series of loads having the coefficient value of y1, y2, again yc, y3 and y4. If you see, the yc is calculated, but the distances are same, then the value of yc will be 6 again. Then maximum bending moment at C if you consider, and the coefficient values of y1. So y1 if you calculate from the support here, so how much it will be 4 plus 2.5, 6.5 minus 10, because we have the span of 10. We need to calculate the distance over here, and this is the total distance. And this distance, what I am showing here, this distance is 2.5 and 4, 6.5, and remaining is here, what is there, 10 minus 6.5. So 10 minus 6.5 will be 3.5 divided by 10. And next is 2.5 is lesser than that. So for this up to here we need to consider. So that is 7.5 by 10. And for YC we have 6. And for Y3 again you need to consider in this span. This is total 15 meter. In this 15 meter we have deducted this 2.5. 2.5 if you deduct, it will be 12.5 by 15. And again for y4 you will be having 2.4, 2.5 and 2.5. In the 15, if you deduct 2.5 two times, it will be 10, 10 by 15. Again the intensities will be multiplied with the coefficient values. With all over we need to multiply yc, then we will be able to calculate 4110 kilonewton meters. So that means when the series of loads are moving from right to left, then the maximum bending moment we can expect on the section C is 4110 kilonewtons. At the same time, if you consider the bending moment moving from left to right, you'll be getting the maximum bending moment on the section is 4140 kilonewtons. So there is a different load bending moments we are getting when the load is moving in either directions. I hope it is clear for you people. If you have any doubts regarding this, please let me know. We have completed with the problem. If you have doubts, please let me know. And I have already shared the notes in your group. Please go through that. If you don't get it, please ask your friends, because I have already sent it long back, 3-4 days back. Or else you can search in the WhatsApp group, you will be getting that. Please download and solve the problems on your own. Until and unless you start solving your own, you won't get the problem solutions. Again, if you got any doubts at any point, please let me know with a call or with an WhatsApp. I'll be there to clear for that. So dear students, you got clear everything what we have discussed today. Yes, Arun.
Yes,
Arun,
sir.
are you listening? Yes, please do reply me. I am asking everyone whether it is clear or is there any doubts.
No.
No doubts.
Moving load.
Shall I move? Shall I move for further? Because the same types of problems I am solving since for a week. I think I have taken 5 classes on this concept only.
Yes, sir. Yes, sir. You take them.
Okay, anyhow. So I just complete these moving loads for the beam, and again here if you see in the question paper pattern, for beams there is a question, and for trusses there is a question. To calculate the maximum bending moment for using influence line diagram using ILD, and there will be an R question like this. At the same time you will be getting the truss question as well as the question which is on the beam. So in this case, I would like to take this truss now with an example, and again everything is same over here. Everything is same over here, but what we know that to calculate or to consider the shear force, bending moment, and reaction support reactions. But in the truss, we need to consider only the forces, compression as well as tension, since we won't get any shear force and bending moments in the truss. I hope you know that in the pin jointed truss, there will not be any shear forces and bending moments because the loads which are acting to the joint itself. So for that reason, we need to have the particular stresses need to be calculated. So for these, there will be a diagonal members, right? There will be an upper chord member. This is an upper chord member, right? And this is an bottom chord member, right? And this is the diagonal member. So there are three numbers of members are there. There are three types of members are there to calculate the stresses which are included in the member. That will be calculated by referring to influence line diagram. So I will just show that. Okay, I hope that it is visible clearly for you. So here, just if you observe, this is a truss. This is a truss having the height of h and the distance of l for each span, and the total will be having 5 times of l. The total distance of the span, or total span of the truss. So here, in this case, if you see, the truss is having the members which are in diagonally, right? Which are having diagonal members, which are having C. I will just show this with the diagonal members. These are right, and apart from that we have a bottom chord member this one, and apart from that we have the top chord members. Right, these are the bottom chord members, top chord members, as well as diagonal members. So for this, for these types of members, again we have another one which is the vertical member, which are these one. So that means whatever I am using color codes, those members will be asked to calculate the stresses. That is the case. You may have to learn in the this particular truss, right? So these are the members that we can expect in the truss. So now here, if you see, when the moving load is on the point here, at this point, because if you see, I would like to explain this concept. So these are the points, right? And this like this, the truss can be expected. I hope you are able to understand this model, right? So when the load is moving in this direction, it will first load on this point, and again it will be on this point, again it will be on this point. So that means whatever these loads are there, these are connected to the vertical members like this. I hope you are getting the diagram what I am trying to explain with three-dimensional. So this is the point load which is moving in this direction, and when this load is on the point, on this point and this point, because it is moving, you can expect the load on any of the points, right? So that means when the load is moving at this point, load is moving at this point, if you if you want to calculate the value of the particular influence line diagram, if you want to draw the influence line diagram for this member, for this vertical member, that will be sorry for this member, because the 1, 2, 3, 4, 5 whatever the numbers are given. In the case in this stress, what do they do is they will just simply ask to calculate the member forces, but they won't say which member. Instead, they say, or they give the notations nearer to the member in which you are going to calculate. I hope you are getting. If you are asked to calculate for the top chord members, they will directly write the number 1 for the nearer to the top chord, right? And at the same time, if you here if you see, in this question they asked for the bottom chord member and the numbers are written at the bottom. And for that you need to consider the bottom chord member. And here they are asked to calculate for the diagonal members and the numbers are written near diagonally, and then you need to calculate the diagonal values, diagonal member values. Right? This is how they will consider for the particular problems. Here I will just explain in brief. In coming class I will take the problems on this, then we could get the problem solution for it. So just we need to know how exactly the trusses are considered for the influence line diagram and how they are going to solve in the with reference to the ILD. Right? For top chord member, if you see, it is the top chord member. If you see having the influence line diagram, it will be lying in this manner. For this, say it is you can say X. And similarly, what we have calculated YC value for the apex point for the bending moment. The same thing we are here considering, that here we are including the height of the truss, which is H over here. So Z into L minus Z divided by H multiplying with the value of L. So in previous case we have considered Z minus L by L only, but in this case we need to consider H also, because the particular member will be having the height. So here the Z value will be this one. That means at which section you are calculating, that will be the Z value, and remaining will be this one. That is the remaining value, that is L minus Z. So this is Z and this is L minus Z. This is L minus Z, like this. And at the same time, if you have for the second section, and at the same time if you have second one, this will be the value of Z, right? And this will be the L minus Z. And for third span, if you consider, I am using color codes if you get it, if you want to get. So again, this if you want to calculate for this third span or third beam, third number, then the Z value will be this one and remaining will be L minus Z. Again, it is similar for this span. This is L minus Z and total will be the Z, since the load is moving in this direction, right? And apart from this, see, similarly the particular loads will be calculating by reference to the sections. So it is the section we are calculating, and now for this section we are calculating this one, and for this section we are calculating this one, like this, right? So at that in which point you are going to calculate the exact values, that point will be having the apex, right? This is how we need to have the calculation influence line diagram for the trusses. Similarly, just the diagram shows everything. At this point, if you have the influence line diagram for bottom chord members, that will be in the this section, because why it is in this section is because the bottom chord members always will be in the tension, when the load is moving in this direction with the intensity, a certain intensity, these loads will be having in the tension, because this will try to bend in this manner, and the tension forces will be considered with the negative sign, and the positive sign will be having the compression sign. Right? That is the sign convention we have already following. Right? So, and on that basis we are considering the section. But for bottom chord members, we need to draw the influence line diagram at the bottom. Right? Again, the coefficient value for the section will be same. So z into L minus z into divided by h by h into L. That is the case. Right? I will just I am showing you, I am explaining the concept. In coming class, I will take the problem on this concept, and you will be able to understand clearly. But before that, we need to know how exactly the influence line diagram will be lying for those types of sections. So for this section, we are having z into L minus z divided by h into L. So this is the case. So the distance will be again the L, the type small distance, and that is the each section having L distance, and total will be 5 times of L. So that is the distances are written as Z will be 2L over here, and L minus Z will be 3L. And at the same time, if you consider for diagonal members, that will be lying in this manner. I am just wanted to show you how exactly the influence line diagrams are drawn for the truss members. And once the problems started, then we are able to understand clearly. Right? So in coming class, I will continue with the problems on the truss members, and those are very simple as compared to the beams. Right? So with this note, we will conclude this class. If you have any doubts regarding this, please let me know. With the diagrams or with the concept, I can be clear for you. If you again we are asking you, if you have doubts now, please let me know. Else we'll conclude this class, and we'll discuss on this by tomorrow. Okay, many students are new today, and I hope all of you have got understood. Again, I request you people, if you have any doubts, please let me know.
On this,
Yes, Vinay.
sir, please share the question banks on these problems only, sir.
Question banks. You want question banks or solutions? Only question banks.
With solution also, okay, sir.
Solution, questions and solutions I have already shared in your WhatsApp group.
Okay, that's sir. Influence diagram notes, no, sir.
I have already shared.
Other than that,
Other than that, which you are expecting, the questions almost 4 questions I have solved, and one question I have given assignment on this concept, influence line diagram. And apart from that, which you are expecting?
okay, sir. Okay, sir. I will go through it, and if question bank is there, sir, only question bank, and then also share, sir.
Okay, no problem. I will share that question banks with I know, only answers. How much the answer is expecting from that question, that I can share with you.
Okay, sir. Okay, sir.
Okay, okay, fine. Any other suggestions or any other queries? Please, and one more request I want to discuss with you people. Don't do that whatever you have done for the SOM subject, because the online classes, if you ignore it, the result will be similar for ADS also, as like your SOM. So again, I request you people, please do concentrate on the subject, try hard to solve the problems, discuss with me or with your friends to get the solution. No problem, I won't mind anything. Again, I can say this much only. Remaining part, if you have any suggestions, you can tell me that I can expect, and then I can move with those words. Okay, with this note, I will conclude this class. The time is over. Please do attend the next coming class. Okay, and thank you everyone for attending the class. And this video will be available in YouTube as well as in your classroom. Please go through it and try solving the problems. Thank you everyone.